Have you ever stopped to think about how a baby learns? I mean, really think about it. It's not like they're reading a textbook, right? It's all just pure trial and error. So what if an AI could learn the exact same way? Well, today we're going to dig into the powerful idea that makes this a reality. And it all kicks off with a really simple question. Yeah, how does a baby learn to walk? Seriously, there's no user manual, no one's writing code for their little legs, so how in the world does it work? It's all about trial, error, and reward. You know, the baby tries to take a step and, whoops, falls over. That's a small penalty. You could call it a negative reward. But that one time they manage to stay up, that's a huge positive reward. They are, and this is the key, literally learning from the consequences of everything they do.
So that brings us to the big question. What if we could get an AI to learn the same way? To build algorithms that just explore their world, figure out what works and what doesn't, and get smarter completely on their own? Well, guess what? We can.
Okay, so this whole concept, this machine that learns, it's not just some nice little story. It's actually the bedrock, the foundational model for a whole field in AI called reinforcement learning. And this quote really nails it. Let's just break it down. Picture that baby, right? They're trying to get to a toy across the room. Every single wobble, every little fall, that's a data point. It's a tiny negative reward. But every successful lunge forward, that's a positive one. And you have to realize, after thousands of these little experiments, the baby isn't just flailing around randomly anymore. Nope. It's actually building a strategy. And that right there, that trial and error process, that is the absolute essence of reinforcement learning. It's a total game changer because we don't program the solution. We just set up the playground, define the goal using rewards, and then we let the algorithm figure out the how all by itself. Okay, so it sounds great in theory, right? But how do we actually take this idea and get a machine to do it? Well, we have to give it some structure. We've got to define the rules of the game the AI is about to play. And this is where we get the formal name for it. It's called a Markov Decision Process, or MDP. Now, I know that sounds super technical, but don't let the name intimidate you. Seriously, all it is a mathematical way to describe the world our AI is living in. Think of it as the baby's room, with all its furniture, toys, and the floor, all the possibilities and all the consequences. And this table here, this is basically our Rosetta Stone. It translates the baby's story into the formal language of reinforcement learning. So the baby, that's our agent. The room it's in, that's the environment. Where the baby is right now, its posture, its location, that's the state. Any move it makes, like a crawl or a step, that's an action. And of course, the result, making progress or falling down, that's the reward. See? Simple when you break it down like that. So what you get is this constant looping conversation. The agent is in a particular state, it takes an action, the environment then comes back with a new state and a reward, and then it just repeats over and over and over. We're talking millions, sometimes even billions of times. And with every single turn of that cycle, the agent gets just a little bit smarter about what works and what doesn't. All right, so the agent is learning, it's collecting experiences. But what's the point of it all? It's not just about wandering around aimlessly. The real goal here is to find the absolute best strategy possible. And in the world of reinforcement learning, that strategy has a name. We call it a policy. Honestly, the best way to think about it is as the agent's brain, or its rulebook. It's the thing that tells the agent, okay, you're in this situation, so you should do that. And yeah, at the very beginning, that policy is totally random. But with every piece of feedback, every reward, it gets tweaked, refined, and made better and better. Now, this is a really critical point. The goal is not just to get the next quick win. It's about maximizing the total reward over time. Think about the baby again. Crawling is easy, it's safe, it's a guaranteed small reward. But to get that massive payoff of walking, the baby has to risk falling down. It has to trade short-term safety for a long-term victory. And RL agents are designed to do exactly that. They're all about playing the long game. This brings us to a really cool distinction. You've got two main ways to solve these kinds of problems. On one hand, you have planning. This works great if you know all the rules of the game up front. Think about a game like chess. A computer can calculate all the possible futures. But what about the real world? Most of the time, we don't know all the rules. And that's where learning comes in. This is reinforcement learning. It's for when you have to figure out the map as you go, not just follow one someone handed you.
Okay, so I know what you might be thinking. This whole baby analogy, it's a nice story, but is it just a toy example? Absolutely not. This exact framework, this simple idea, is being used right now to tackle some incredibly complex and high stakes problems. So remember that simple little loop we talked about? That constant back and forth of state, action, and reward.
Well, get this. That is the exact same logic an AI uses to manage a massive, complex investment portfolio. The state is the current market condition. The action is whether to buy or sell, and the reward, well, that's the profit or loss. It's the same pattern.
And it goes even further. This is the logic used to build high-frequency trading algorithms that make decisions in microseconds, learning the crazy complex dynamics of a stock market order book. So yeah, believe it or not, the baby learning to walk and the AI learning to trade are, fundamentally, solving the exact same type of problem.
So let's just pull all this together and talk about what really makes reinforcement learning so incredibly powerful.
Okay, what do you need to remember? First, it learns by doing. No instruction manual needed. Second, it's all about that long-term cumulative reward, not just a quick win. Third, and this is huge, it learns how to balance exploring, trying new stuff, with exploiting what it already knows works. And finally, because of all this, it can tackle problems that are just mind-bogglingly complex. Problems with so many possibilities you could never, ever write a traditional program to solve them.
And that really is the fundamental shift here. It's a completely different way of thinking. We're moving away from being programmers who have to spell out every single step. Instead, we're becoming more like coaches. We just set the goal, define the rules of the game, and then let the AI, the player, figure out for itself how to win. We're already seeing this everywhere, from AIs that master the world's most complex games to algorithms navigating our financial markets. And all that leaves us with one pretty mind-blowing question to think about. If you can give an algorithm a goal and it can figure out how to achieve it from scratch, what problems are we going to solve next? What are the real limits here?